tells us a point. Find the equation of the plane through the origin. So for 24, they give us the 1 point, which is nicely described as 0, 0, 0. And it says, find the equation of the plane through the origin and perpendicular to both of those things. What are these? So x minus y plus z equals 5. And 2x plus y minus 2z equals 7. So it needs to be perpendicular to both of those things. Perp to both. So how do you find a vector? How do you find a vector that's perpendicular to both? You take the cross product of
the vector that's on the two normal vectors of the plane.
So you want to be perpendicular to both of those planes. So how do you what do we know from both? Let's just disassemble this a little bit more clearly. So what can we tell directly from this? We know that the normal vector for, we'll call this one B. We know the normal vector for B is 2, 1, and negative 2. And if this is A, we know the normal vector for A is 1, negative 1, and 1. So we have two vectors that are perpendicular to both, right?
Yeah.
If we were to cross those, we'd have a vector that's perpendicular to both perpendiculars,
which is
parallel to the original, right? But is that what we want?
No, we're looking for the plane that is perpendicular.
Exactly. So if we look. This is what we did last class. Is we crossed these two to find a vector that was parallel to the line of intersection, right? If we were to cross these two right now, we would get a vector that is parallel, that is perpendicular to the normal vectors of both, which is therefore going to be parallel to both planes. So if we wanted a plane that is parallel to both planes and goes through the origin, hold on, let me finish the sentence and then you can go to where we're going next, Matt. Yes, we don't want that though. We want something that is perpendicular to both of them. Perpendicular to both of them. Any ideas of what we can do to find that? B are not necessarily perpendicular to each other. I'm just drawing them. They look like, it's just easiest to draw when they're kind of close to perpendicular. About that purple line of intersection. That purple line of intersection is perpendicular to the plane we want. The purple line is perpendicular to the plane we want, right? So how do we get that purple direction? What's the easy way to get that purple direction? Correct. So if you do, if you do NA cross NB, what do you end up with? Something that is parallel to the what? The purple, right? Are you with me so far? And the purple, you know, is, and I can't spell today, that's fine, I'm okay with that. You know, the purple is perpendicular to the plane we want. So therefore it's the normal vector of the plane we want. Vector of the plane we want, right? Are we okay so far? We want. So if you find that normal vector, we have a path to find the normal vector, and we have a point. What's the point we're using? Origin. You just plug it in. Just plug it in. Okay. So right now, when you cross NA cross NB, you end up with the vector 1, 4, 3, like this. So therefore, what's the formula going to be? It's going to be x times, sorry, not x, 1 times what? X minus, I'm just doing out all, plus
4 times
y minus 0 plus 3 times z minus equals what?
0.
Equals 0. So what do you end up with? X plus 4y plus 3z is equal to 0. Yeah. I will tell you that the hardest part for me, and you might have different ways for things to be hard, right? One of the hardest things for me is some of these problems, you'll understand, you think you get to a point where you're in this nice comfortable box of understanding, and then you examine it some more, and by examining it some more you create even more complications. It is really easy to overthink these and make them more complicated than they are. That doesn't mean that these are easy problems. That is the challenging part about these. In 2 dimensions, it's really easy to see certain things that are very hard to see in 3. If I have a line, and I know that they're perpendicular, right? And I know that that same line is perpendicular here, what do you know about these two lines? They're parallel, right? The same thing holds true when you're talking about planes, like perpendicular to perpendicular, or back to the same plane or parallel, right? But it's a lot harder to see. I was trying to sketch something out, and it's a pain. It can be very hard. Okay, so you want, when doing these problems, especially ones where the points are really nice, did any of you actually graph this or just kind of see what it looked like? That's what I do. I mean, when you graph these, it's not that bad to graph them in 3 space because they're all on, what's the z value on all of these? Well, there is a z value. It's what? It's 0. Yeah, it is ling. It's not nothing, right? It's going to show a nothing. How do you say nothing? Like ling is 0, right? How do you say nothing? Mayo? Would you say mayo? Okay. Mayo Busher Ling, I guess is what I'm saying. So 0, 0, 0, we have point 1, right? So that's this point. And then we have, I'll also use the same color. And then 0, 1, 0. So let's say that's out here. And then you get 2, 1. So you have this point right here and this. So you have this shape. It's a rectangle, right? Are you with me so far?
Yes.
Are you with me so far? So what did I tell? What do cross products tell you? Cross products tell you 2 things. What's one thing cross products tell you, Jesse? You can
normal vector.
You can use cross products to find the normal vector to 2 vectors, right? And it also tells you what?
The area of a parallelogram.
Is that a parallelogram? It is a parallelogram, right? So when you look at that, you can do this many different ways. But how many vectors do you need for this for cross product? 2 of them, right? So I say we go after this vector. So this vector, do you see that one? And that vector. We go from the vectors that start at the origin. So can you tell me what's this vector right there? What is that one?
J.
Awesome. I thought usually I write them as 3 and then we simplify. It is J. That's all it is. You're right, because what's the magnitude of that? 1, right? And then what's the magnitude of this one right here? It's 2, so it's 2I, right? So and it says very carefully, oriented so it faces downward. So when you cross these 2 vectors, which one's first and which one's second?
It doesn't matter.
No, listen, it says orientated so it faces downward. Down, right?
So J first.
J first, thank you.
I understand why.
I'll show you, okay? J cross 2I. When you do J cross 2I, could you do that mathematically? Do you have faith you could do that, right? What is that? Let me just do it out for you, okay? If we cross these 2 in 3 dimensions, what is vector J? Vector J is 0, 1, 0, correct? And what is vector 2I going to be? 2, 0, 0, right? When you cross these things, you have to do the 3 by 3 determinant, correct?
Yeah.
So when you cross them, when I said you do this out, you do I, J, K, correct? And then you have 2 more lines here. Which one do you put in the middle and which one do you put on the bottom?
2, 0, 2.
Do you want to do 2?
No, 1, 0.
Which one do you put first? So look, 0, 1, 0, 2, 0, 0. If you were to do this cross product, you get I times, what is it? 1 times 0 minus 0 times 0, right? You with me so far? Minus J times what? 0 times 0 minus 2 times 0. Is it good that we're getting a lot of zeros? Yes. Plus K times what? 0, 0, 2, 1, right? 0 times 0 minus 2 times what? 1. So when we do this out, what do you end up with? 0I minus 0J minus what? Minus 2K, right? Here's the thing. If you were to switch the order of this, you 2, 0, 0, 0, 1, 0, these stay the same and they're still 0, right? But when you do this one out, these end up switching positions.
Aren't we doing area?
We are. So listen, I understand. Let me finish. Okay, hold on a sec. Hold on. The area is the magnitude of the vector, but it's specifically saying not only find me a vector whose magnitude is the area of the parallelogram in this case, but make it so that it faces downward. There's an added 6 words at the end of 42. Orientated so it faces downward, right? So if we cross it the other way, what does this one come out to be?
2K.
2K. So this one's up, right? And this one is down. James, yes?
Explain again the right-hand rule.
The right-hand rule is this, right? Okay. So as far as I understand it, and you guys are going to have to help me clean this up because I get confused. Like Tori was explaining, there's so many different right-hand rules that sometimes you end up thinking with your left hand. I don't know. What do we have? It's sinister. I blame it all on the Latin. using sinister or whatever. Okay, so the basic idea here is this. If you have, let's say, vector u and vector v, like this, if you cross u cross v like this, if you cross them, what you do is you put your right hand on u and you curl it to v. Where's my thumb pointing?
Upward.
Up, okay? Do you understand what I'm saying?
Yeah.
If you were to go from v to u, you can't curl your hand backwards, right? You break your fingers. So what do you have to do?
Reverse.
You flip it and you go from v to u. It's going to point downward.
So, but in this, it's a rectangle. So what's keeping you from choosing a different?
No, listen. So all they're saying on this is you have to be very careful about understanding what they're asking. All they're asking you for is find the vector representing the area of the surface. Either of these vectors, the magnitude of both of those represents the area of this right here, but only one of them is pointing in the direction we want. If this question was asking find a vector whose magnitude is the area of this parallelogram, you could pick either one. But the question is specifically asking find the one that's oriented. Why did I say orientated? Oriented. It does. Oriented so it faces downward. They just want you to pick one of the. All they're trying to get you to understand is depending on which way you cross, it's going to go up or down, or one way or the other. Yes.
Could we just
the two directions when you cross two vectors? If you have two vectors that are on the xy plane, it's either going to when you cross them, it's either going to go straight up the z-axis or straight down the z-axis, right? But if I tilt the two vectors a little bit, right? If I tilt it like this. One direction could be this direction and one direction could be that direction, right? You can't just use the word like up and down anymore, right? One of them is like more up on the z-axis than the other. Do you understand what I'm saying?
Yeah.
So yes, you could do it that way. Just clearly drawing it would be helpful, hopefully, unless you don't know how to draw a rectangle, which could be challenging.
so?
This is kind of a cheap question. This is hard for the wrong reasons, but I like it. We have a parallelogram, right? And they're asking for a vector whose magnitude is equal to the area of the shape. So we did this. We like found this down 2, right? For that last one. All they're saying right now is you have a circle like this, and it says it's a circle of radius what?
2.
Circle of radius 2. It's on the YZ plane, right? I'm sorry, YZ plane. That one's going to be like, oh, right here, right? So you have a circle of radius 2. So what's the area equal to? 4 pi, right? So they're saying in the direction of the positive x-axis. So what's the answer to this one's going to be? 4 pi I. So you guys, I understand why you thought it was harder than it was, because you're like, how do you use vectors to find the area of a circle? You know what I mean? I understand it. I get it. That was my reaction. I was like, I don't know how to do it. Because deriving the formulas for areas of circles or spheres is not trivial. You've done that before with limits? Have you ever seen those proofs before?
Yeah.
They're not straightforward. It's a little nasty, right? Basically, you're determining things like where pi comes from, right? It's not easy. So they're not asking you for that. That's it. Okay. So we're